Here we have our graph. It's been shifted 3 to the right, 2 up. So I'm going to transform my vertical asymptote, shift it 3 to the right. I'm going to translate my horizontal asymptote. It's going to go +2. Again, I can change my table of values. The two reference points I had were -1, -1, 1, and 1. So the transformed coordinates become 3 to the right, so +3, +3, 2 up, so +2, +2. And then I have my reference points, 2 over 1 up, there's my point, and 4 over 3 up. Those are my references, and I can sketch in my transformed reciprocal function. Okay, so there it is. And again, if I want, I can plug in 0 to get a y-intercept. Okay, you can get a y-intercept value there if you like, but we have our main points, our asymptotes, and our two vertex points. Here we have a vertical expansion. So that 3 represents a vertical expansion. So I'm going to just do my shifts first. So I can do my vertical asymptote does not change. I know my horizontal asymptote is going up +1. Now my points of reference, my 2 points of reference, -1, 1, and +1, 1, we have to make sure that we account for that transformation. So it's going to be a vertical expansion. So there's no horizontal. So I'm just going to maybe draw this in. So there's no horizontal change here. So we're still going to use -1 and 1 as our reference. But we're going to have a 3 times vertical expansion, then a shift of +2. Okay, this should have been +2. Okay, or sorry, it's this is going to be a +1. Sorry, this should be vertical shift of +1. Okay, so just change that in notes, and we're going to do ×3 + 1. We get a y value of 4 times 3. Sorry, not 4. This is going to be. This should have been -1. So ×3 + 1 is going to give us -2. ×3 + 1 gives us +1. So there's my references. -1. I'm going to go 2 down. So point right there. 1 over. And 4 up. 1, 2, 3, 4. Okay, and this represents a 3 times expansion, because normally it was 3 from the middle, 1 from the middle, but now it's 3 up from the middle. So now it's going to go through that coordinate there. So then I have my reference points. I can sketch that in. There is a symmetrical point over here, which we didn't show, but it does exist. Okay, so there it is. There's my rational function. Okay, and I have my expansion shown with this reference point. And this point here essentially shows my expansion, because I can see that instead of going 1 down or 1 up, I've gone 3 down, and from the center I go 1 over, 3 up. So our positive expansions normally go in these quadrants, and our negative expansions means we're going to flip. So the graph is going to look like that. Okay, so that's what a vertical flip would look like, and that is affected by that A coefficient, and we'll see how that affects our graphs later on as well.